Hey folks, so in the previous video we set up a Kubernetes cluster on a GPU node with NVIDIA operators. Everything was done manually in this video, but today I want to kind of streamline the process and make things a bit cleaner. So I have this repository here where we will clone it in a moment, and we'll see how this repository helps us to set up a single node cluster. For my use case right now, I provisioned one RTX 3060 machine. It's a decent machine. It has 12 gigs of VRAM, just one GPU, which is enough for my use case, and then a bunch of information about the system RAM and CPU information, right? So as we know, in VastAI, after you provision your machine, you'll get the SSH connect options. So let's copy that, and then we will SSH into our machine. So we have root access, we're in the machine, right? So let's clone this repository, GPU-VastAI. So I'll add this in the description as well. So if you guys want to try it, you can give it a shot. And then, so, okay, yep, I have cloned, I'll just confirm that. And I have the GPU VastAI folder, inside which I should have the scripts that I need. Okay, so yeah, there's two different folders, right? One is Kubernetes, one is Python scripts. So Python scripts is a bunch of scripts that I'm just, testing with PyTorch. And then all the scripts that need to form the Kubernetes cluster are inside this folder. So let's get in there as well. And then we can see a bunch of scripts here, right? So what we will do is, so as of now, we have a Kubernetes cluster in a single GPU node. So this node will be used to schedule the control plane and the data plane stuff as well. Eventually, when we have more nodes, then we will segregate the control plane and the data plane stuff. And then after my cluster is ready, then I will use Helm, Prometheus and Grafana Helm charts. I have NVIDIA pods, I'll have GPU operator pods as well. For all of this installation, I've used Helm charts. And then we will have a dashboard where we will have the GPU matrix pulled out, and we'll monitor things like GPU utilization, the VRAM utilization, power users, and many more things, right? So this is kind of like a work in progress. So eventually we will have better dashboards, maybe more streamlined scripts and so on. So to run this, all I have to do here is run this command, run all.sh. So once I run this, it will go ahead and run these scripts in a certain order. Once that order is completed, then we should have a working Kubernetes cluster ready. If you want to learn how I did these things manually, you can check the previous video setting up Kubernetes cluster. So I did everything manually in this one, but here I just made a script because I have to do this, quite frequently. Okay, folks, so the script has completed. It has installed a Kubernetes cluster, and then there are a couple of namespace here now. So kube system, where all of our control plane stuff is there, and then my monitoring namespace where I have my Prometheus Grafana related pods, and then we have a default namespace where we have our NVIDIA and our GPU operator pods as well. So the setup so far is, we have a Kubernetes cluster in a single GPU node. We used Helm to install all of these repositories, and now we will have a, oh my god, like keyboard as I get on. Okay, 1 2 3 1 2 3 go. Hey folks, so my script has completed. Now I have a working Kubernetes cluster with this 3 namespaces and a bunch of pods, right? So my Prometheus Grafana pods are in my monitoring namespace, and then I have some GPU operator and NVIDIA related pods in my default namespace, and all the stuff from control plane is in the kube system namespace, right? So the stack so far is I have a working Kubernetes cluster built on a single GPU node, used Helm charts to install all of these things, right? And the next goal is to build a Grafana dashboard where we'll pull in these different metrics and we'll start monitoring our GPUs. And you might have noticed, right, there are a couple of pods here. I will kind of briefly talk about the NVIDIA and GPU pods. So these pods and monitoring namespace are, Grafana Prometheus pods, right? So I won't be talking much about these guys. And then the kube system is all of our control plane related stuff, right? So let's talk about our GPU and NVIDIA related pods. So GPU operator, right? So essentially, this is the main operator controller. It watches the entire Kubernetes cluster and then ensures that all of the GPU components are installed correctly, right? Kind of, we can think of it like a manager that checks all GPUs are healthy or not. So having, a running GPU operator pod is absolutely important. And then we have our GPU feature discovery part, right? So this is an NVIDIA specific feature of like node feature discovery. So essentially what this part does is that it will query the NVIDIA drivers on the GPU and then provides us with, you know, fine-grained GPU info back to the Kubernetes cluster, right? So in Kubernetes, we know that, you know, pods are very important to maintain a state of the cluster. Each pod has its own responsibility. So in this example, like our feature discovery is an important pod which tells GPU information to our Kubernetes cluster. And then we have other important pods like NVIDIA Container Toolkit. So essentially we need the container toolkit to integrate our GPU with containerd. If without that, you know, containerd won't be able to run, you know, like it won't integrate with GPUs, right? And then we have the NVIDIA device plugin daemon set as well. So this bridges the gap between Kubernetes and GPUs. It will advertise GPUs to the kubelet so we can request like GPU pods in our pod spec. And then the most important one for our dashboard will be the NVIDIA DCGM Exporter. So we can see that pod in, let me check where that pod is. Container Toolkit, Operator Validator. This is the pod, yep. So that's the one that I'm talking about. And then what DCGM Exporter does is that it will expose all the metrics by Prometheus, the metrics like temperature, memory, and users, so we can build our Grafana dashboard, right? So the setup in Vast AI is a bit different. To be able to log into our Grafana dashboard, we have to do this. So let me click on the connect option. Let me copy that. Okay, so before I can open my dashboard, right, like I need to have a public IP where I can, you know, add the IP address and then the port of my Grafana. But like that kind of setup in a normal public cloud is a bit easier, but in Vast.ai, this is the way we have to do it. So in my remote machine, I have it exposed. I have my Grafana on port 80. So I will remove that to port 80. And then what I will do is I will use my local port 3000. So essentially what I'm saying is that I will use the same way to connect, but in this situation, I will map my local port 3000 to remote port 80 in my remote machine, right? So when I connect like that, now I can use localhost 3000 and I see my Grafana dashboard, right? So if I don't have this active tunnel, I won't be able to use Grafana because my port is not mapped, right? So if I go refresh, you see I'm not able to connect. But if I do this, where essentially I'm mapping my local port 3000 to the remote machine port 80, creating a SSH tunnel in that machine, then this will work. So let's give it a refresh and we see its Grafana is working, right? So even let's look at the service here. kubectl get service -a. So we see our Grafana is on port 80. That's why we mapped it with port 80. So the default admin password for Grafana is, you know, admin and prom operator. But when you do the cluster setup, it'll give you the command which you can use to get your default password. But in my case, it's, you know, in everyone's case, I think it's just the admin and prom operator. So once I log in, I can see my Grafana now. So let's expand this a bit more, and then we can see some default dashboards, right? So this tells us that Grafana is working in our cluster right now. So let me go to dashboards, and then, so by default, we have these Kubernetes related dashboards. So let me check core DNS. Okay, so essentially that's when we set up our cluster, right? So if I change this to last 15 minutes, so we can see some traffic's going on in our cluster already, right? So this tells us that we can now successfully pull information from our Kubernetes cluster, send it to Prometheus, and then Grafana extracts it from Prometheus. So there we go. We have a working setup. So what we will do in next video is we will build GPU related dashboards and we will pull GPU related metrics. There are a couple of things I need to do before we can do that, which I'll show it in the next video. And thank you for watching this one.